Module 5. Three-dimensional works of art. Clay. There are three categories of clay: earthenware, stoneware, and porcelain. Earthenware clay is a low-fire clay with a porous and rustic quality. It is less durable and more porous than other clay types, requiring glazing or sealing to make it watertight. It is commonly used for pottery, tiles, and decorative objects. Stoneware clay is a mid-fire clay that is denser and more durable than earthenware. It is fired at higher temperatures, resulting in a vitrified, non-porous surface. It is suitable for functional and decorative ceramics, including tableware, vases, and sculptures. Porcelain clay is a high-fire clay that is translucent when thin and fired to maturity. Porcelain is fired at the highest temperatures, making it strong, vitrified, and non-porous. This process is called firing. It is often used for fine china, figurines, and delicate ceramics. Porcelain requires careful handling and precise firing to achieve optimal results. Glass. Artists working with glass utilize a variety of techniques to manipulate this unique material and create stunning artworks. Here are a few common techniques employed in glass art. Glass blowing is a traditional and widely recognized technique. Artists gather molten glass on the end of a blowpipe, then use their breath or tools to shape and manipulate the material. This technique allows for the creation of various forms, from vessels to sculptures, by controlling the heat, blowing air, and manipulating the glass while it remains malleable. Fusing involves heating multiple pieces of glass in a kiln until they melt and fuse together to form a single, solid piece. Artists can layer different colors, shapes, and textures of glass to create intricate patterns and designs. Fusing allows for the creation of flat panels, bowls, plates, and sculptural forms. Slumping is a technique used to shape glass by heating it until it becomes soft and pliable, then allowing it to slump or drape over or into a mold. This technique is often used to create bowls, vases, and other curved or molded glass objects. Lampworking, also known as flame working or torch working, involves manipulating glass rods or tubes over a flame to shape them into intricate designs. Artists use a torch to melt the glass, then employ various tools and techniques to create beads, sculptures, and intricate glass objects. Glass artists can also etch or engrave the surface of the glass using abrasive materials or tools to create designs, patterns, or textures. This technique allows for intricate detailing and can be used to add depth and visual interest to the glass. Metalworking encompasses a range of techniques used to shape and manipulate metal into functional objects. Here are some commonly employed techniques. Forging involves heating the metal and shaping it through the application of force with a hammer or press. This technique allows for the creation of intricate shapes, such as blades, tools, and ornamental elements. Welding is the process of joining separate metal pieces together by melting and fusing them using heat and pressure. It is commonly used to create sturdy and durable structures, including furniture, architectural elements, and sculptures. Casting involves pouring molten metal into a mold, allowing it to solidify and take on the shape of the mold. This technique enables the production of complex and detailed objects such as decorative hardware, jewelry, and small sculptures. Forming techniques, such as bending, rolling, and stretching, are used to shape metal sheets or rods. These techniques are employed in the fabrication of objects like metal vessels, bowls, and architectural components. Machining involves using specialized tools, such as lathes and mills, to remove excess metal and shape it precisely. This technique is commonly used in the creation of precision parts and components. Three traditional methods used in textile works are weaving, embroidery, and dyeing. Weaving is a traditional textile technique that involves interlacing two sets of yarn or threads, known as warp and weft, to create a fabric. This method is commonly used on looms, where the warp threads are stretched vertically, and the weft threads are woven horizontally across them. Weaving can produce various patterns, textures, and designs, and it is used to create fabrics such as cotton, silk, wool, and linen. Embroidery is the process of decorating fabric using needle and thread or yarn. It involves stitching patterns, designs, or motifs onto the fabric surface. Embroidery can be done by hand or with the help of embroidery machines. It is often used to add intricate details, embellishments, and decorative elements to textiles, including garments, home decor items, and artwork. Dyeing is a technique used to impart color to textiles. Traditional dyeing methods involve immersing the fabric into a dye bath or applying the dye directly onto the surface. Natural dyes, derived from plant materials, minerals, or insects, were commonly used in traditional textile works. Techniques such as tie-dye, batik, and shibori involve manipulating the fabric before dyeing to create unique patterns and designs. Materials used in art. Traditional architectural materials and methods vary across different regions and time periods, but they often share common characteristics. Traditional materials include locally sourced materials such as stone, wood, clay, adobe, thatch, and brick. These materials provide durability, insulation, and a connection to the natural environment. Traditional construction methods often involve skilled craftsmanship, such as stone masonry, timber framing, and earthen construction techniques. These methods prioritize structural integrity, functional design, and cultural aesthetics, reflecting the local traditions and historical context of the architecture. Modern materials like concrete and steel have revolutionized architecture, allowing for the construction of buildings with unprecedented scale, strength, and versatility. Concrete, with its ability to be poured into molds and molded into various shapes, has enabled the creation of structures with curved forms and complex geometries. Steel, known for its strength and flexibility, has facilitated the construction of tall and large-span buildings, including skyscrapers and bridges. These materials have also facilitated faster construction processes and have contributed to the development of modern architectural styles, characterized by sleek, minimalist designs and innovative structural systems. Their introduction has fundamentally transformed the possibilities and aesthetics of architecture, leading to the rise of modernist and contemporary architectural movements. Recent innovations in construction techniques and materials have opened new possibilities for architectural design, leading to the development of innovative and dynamic architectural forms. Here are a few examples. Sustainable materials. The growing focus on sustainability has led to the use of environmentally friendly materials, such as recycled or renewable resources, in construction. These materials, such as bamboo, engineered wood, and recycled steel, have enabled the creation of eco-friendly buildings with unique forms and structures. Advanced structural systems. The use of advanced structural systems, such as tensile structures, cable networks, and parametric design, has allowed architects to create buildings with intricate shapes and unconventional forms. These systems distribute loads efficiently, enabling the construction of lightweight and visually striking structures. Digital fabrication. Technological advancements in digital fabrication, including 3D printing and robotic construction, have revolutionized the way buildings are constructed. These techniques offer precise control over the fabrication process, allowing for the creation of complex geometries and customized components. Smart materials. The integration of smart materials, such as shape memory alloys, self-healing concrete, and photovoltaic panels, has transformed the capabilities of buildings. These materials can respond to environmental conditions, optimize energy efficiency, and provide interactive features, resulting in dynamic and adaptive architectural forms. Parametric design. Parametric design tools and algorithms have empowered architects to create highly intricate and organic architectural forms. By using computational modeling, architects can explore and manipulate complex geometries, resulting in visually striking buildings that push the boundaries of traditional architectural design. Contemporary environmental concerns have had a profound impact on architecture. Architects are increasingly incorporating sustainable design principles to reduce the environmental footprint of buildings. This includes strategies such as energy-efficient designs, use of renewable materials, and integration of renewable energy sources. Additionally, there is a focus on creating buildings that harmonize with their natural surroundings and minimize their impact on ecosystems. The goal is to create environmentally responsible and resilient structures that promote a more sustainable future and address the urgent need for climate action.